In this video, we want to find the product of these two matrices here, and then we want to make a conclusion based on the result. So first, let's go ahead and multiply these out. And again, remember, it's not the corresponding components multiply, so it's not the first one here times the first one here, second one here times the second one here, and so on. It's the row multiplying into the column. So the minus 7 over 27 multiplies the 1, multiplying the first column. So the components of the first row over here multiply the components of the first column. So this will be a minus 7 over 27. Then 2/3 times 0 is 0. And 17 over 54 times the 4. We can reduce that, and that'll be a 34. The 2/3 times the 0, of course, is 0, so it's 54 divided by 2 is 27. That'll go down here. And then we have a 2 left over times the 17 will give us a 34. Then we add this up, we get 27 over 27 equals to 1. So let's partially fill it in over here. First component of the answer is 1. That's what we got over here. And then again, the first row, using the first row, we multiply the corresponding components of the second column, and that'll give us the second component of that first row over here of the answer. So negative 7 over 27 times negative 2 will give us a 14 over 27. And then the 2/3 multiplies the 3 here. Cancels the 3, gives me a 2. So this will be a plus 2. And then it's plus 17 over 3, or 2 over 3 rather. 2/3 multiplies the, so now 17 over 54 multiplies the minus 8. Yeah, again, you can reduce that by 2. So this will give me a 27 down here. And then the negative 4 is left over on top, so negative 4 times 17 is a negative 68. And then this 2 here, let's get the same denominator here, so let's multiply by 27 here. Put 2 over 1, multiply by 27, and this will be a 54 over 27. So this is replacing the 2 there. And then a 14 over 27 and 54 over 27 is 68 over 27. We have a minus 68 over 27 here. So this comes out to 0. So this component here in the second row is 0. And now we do the same thing with the first row, multiplying through the components of the third column. So this will be a negative 7 over 27 times the 5. This will be a minus 35 over 27. Again, multiplying the components of the first row into the corresponding components of the third column. So minus 35 over 7. And then the 2/3 multiplies the 1. This will be a plus 2/3. And it is plus the 1750 over 54 multiplies the 2. And let's reduce it, divide the 2 into the 54, so this will be 17 over 27. And then this 2/3 here, let's multiply by 9 and 9. So this will give me 18 over 9. 2/3 multiplied by 9 here and 9 up here gives me 2 times 9 is 18, and 3 times 9 is 27. So this comes out to 27. So then what do we have? So this is how we have 18 over 27, and 17 over 27 gives me 35 over 27. But here I have a minus 35 over 27, so this is equal to 0. So the components for this row are 0. Now to get the second row of the answer, we do the same thing we just did, but now we're using the second row of this column right here, of this matrix right here. So it's going to be negative 2 over 27. Negative 2 over 27 multiplies the entries of the first column. So negative 2 over 27 times 1 is negative 2 over 27. And then I got a plus here. Then it's the 1/3 times the next component of that column will be 0. Then it's plus, and then it's the next component of that row times that's component over here, so it'll be 4. And let's reduce this, divided by 2. This will give me a 2, and then over 27. So 1 over 54 times the 4. Divide 2 into the 4, I get 2. Divide 2 into the 54, it's 27. We got minus 2 over 27 plus 2 over 27. That's equal to 0. So this component here is 0. And I hope you can see what's happening now. Then I would take the entries of the second row, and the negative 2 over 27 multiplies the negative 2 here. The 1/3 multiplies the 3 here, and then the 1 over 54 multiplies the negative 8. Find common denominators if you want to add them up, which is what you want to do, and this should give me a 1. And then we do the same thing with the final column. So the negative 2 over 27 multiplies the 5, the 1/3 multiplies the 1, the 1 over 54 multiplies the 2. Reduce that and add, get a common denominator. This should be 0. And finally, you do the same thing with the last row over here. These components, 2 9s, 0, negative 1 over 18, multiply into the components of the first column, second column, and the third column. So it would be 2/3 times 1, 0 times 0, minus 1 over 18 times 4. You combine that, this will be 0. And you do the same thing with the second column. 2/3 times negative 2, 0 times 3, negative 1 over 18 times minus 8. Reduce and add. This will give you 0 here. And then finally you do the same thing with the last column. 2 9s multiplies the 5, 0 multiplies the 1, minus 1 over 18 multiplies the 2. Reduce and combine. This will give you a 1. So what do we get? We get the matrix 1 0 0 0 1 0 0 0 1. This is your 3 by 3 identity matrix. That is your multiplicative identity. This is the identity for multiplication. So what conclusion do we make? Well, anytime you multiply two components, even in regular numbers in algebra, when you multiply 3 times 3 to the negative 1, which is the same thing as 1/3, and the multiplicative identity for multiplication with numbers is 1. 3 times 1/3 is 1. So these two are multiplicative inverses. Now in this case, we got the multiplicative inverse. We multiply these out, we got the identity. So these actually have to be inverses. So if I call this one A, then this has to be A inverse. Or vice versa, if I call the first one A, then the second one is the inverse. So the conclusion again is that these two matrices are multiplicative inverses of each other. Thanks for watching. We'll see you next time.